All right, let's get right into it. Today, we're going deep into the blueprint of blockchain. We're going to break down its fundamental architecture piece by piece so you can see exactly how this technology is designed to create trust and to do it without any single person or company in charge.
So, to really get why blockchain's architecture is so revolutionary, we have to start with the problem it's trying to solve. Let's just look at a super simple transaction. Joe wants to send Ann $50. Now, in the world we all know, the traditional model on the left, a bank sits right in the middle. It takes Joe's money, makes a note in its private record book, gives the money to Ann, and of course takes a little fee for its trouble. But on the right, you see the blockchain way. Joe sends the money straight to Ann. There's no middleman. Instead, a whole network of people confirms it happened.
And right there is the crucial point. That traditional model puts all the power, all the trust, and all the control in one single place, the bank. And that's not just more expensive. It creates this huge vulnerability. I mean, think about it. If that central bank system goes down, or gets hacked, or makes a mistake, the whole thing can just grind to a halt. So the really big question becomes, how could Joe and Ann possibly do this without that powerful central authority?
Well, the foundational solution is this incredible idea called a distributed ledger. So instead of the bank having one private notebook that nobody else can see, imagine a magical shared notebook. And the magic here is that everyone in the network gets their very own identical copy. So when a new transaction happens, it's not just written in one secret book, it's written in everybody's book all at once.
Okay, but wait a second. That solution immediately brings up a new and really tricky challenge, right? If you've got thousands, maybe millions of copies of this notebook scattered all over the world, how do you coordinate them? How do you make absolutely sure that when Joe pays Ann, every single copy of that ledger gets updated correctly and at the exact same time without any mistakes or contradictions?
The answer lies in how all the participants are connected. Blockchain architecture uses what's called a peer-to-peer network, or P2P. You can think of it like a neighborhood watch instead of a central police station. Everyone is connected directly to their neighbors. Information doesn't go to a central hub and then get sent back out. It just spreads directly from person to person, from peer to peer, creating this really resilient web of communication.
So how does information actually travel on this thing? It's pretty cool. When a user submits a new transaction, it gets broadcast out to all the other computers. We call them nodes in this P2P network. And it spreads using something called a gossip protocol. And yeah, it's pretty much what it sounds like. One computer tells its neighbors, who then tell their neighbors, and on, until the news of this transaction has rippled across the entire system. Then each and every node checks that transaction against their copy of the ledger to make sure it's valid before it gets bundled up to be added to the chain.
And this table just lays it all out, plain and simple. A centralized network has that single point of failure. You take out the center, and it's game over. The whole system collapses. But a decentralized peer-to-peer network, where control is shared and data is synchronized among everyone, is incredibly resilient. You'd have to take out a huge number of individual participants to damage the network, which makes it just fundamentally more robust and secure.
Okay, this all sounds pretty great in theory, but it brings up another really practical question. Who are these people? These participants in the network? Who's actually doing all this work of checking transactions and maintaining this shared notebook? And more importantly, why would they bother to keep the network honest? What's in it for them?
Well, in the world of blockchain, we call these participants nodes. A node is really just a computer that's connected to the network, running the software. And these nodes, they're the true backbone of the whole system. You could think of them as the distributed volunteer guardians of the network. They're the bookkeepers, dedicating their computer's resources to make sure every single entry in that shared ledger is legitimate.
And if you're a full node, you're basically one of the super guardians, doing all the heavy lifting. You're accepting new transactions as they come in, you're validating them against all the rules of the network to make sure no one's cheating. Then you pass those valid transactions along to other nodes. And, this is crucial, you store a full, complete, up-to-date copy of the entire blockchain ledger. This is what allows you to have a say in the consensus process, the process of agreeing on which new blocks get added to the official record.
So, you take these three core pieces, right? You have the shared ledger, the P2P network that connects everybody, and all of these dedicated nodes doing the work. And what you get when you put them together is a self-governing system. It's a system that's built from the ground up on transparency and collective agreement, able to establish trust without a central boss. But as this kind of system grows, it starts to run into some unique growing pains.
And this is where we hit one of the biggest, thorniest problems in the entire blockchain universe: scalability.
What works just fine, nice and smooth, with a few thousand users, can start to really creak and slow down when you try to scale it up to handle millions or even billions of users.
This quote from our source material just absolutely hits the nail on the head. It gets right to the heart of the issue. For the system to be secure, every single one of those full nodes has to do all the work. Every node processes every transaction and stores a copy of the entire history of the blockchain.
And that design choice, while it's fantastic for security, creates a massive processing bottleneck. It creates a kind of traffic jam. This gets at a famous challenge in this space called the blockchain trilemma. The basic idea is that you want three things: decentralization, security, and scalability. But it's incredibly difficult to have all three at once. For a lot of blockchains, adding more nodes makes the network more decentralized and more secure, but it also slows the whole thing down, which really hurts its ability to scale.
So how do you solve this? Well, one of the smartest solutions being developed is to think in layers, kind of like how the internet itself is built. By separating different jobs onto different layers, you can optimize each part. So at the very bottom, you've got the consensus layer. That's all about how the nodes agree on what's true. Above that, an economic layer handles the currency and the incentives that keep everybody playing fair. Then you might have a services layer for things like smart contracts. And finally, at the very top, the application layer, which is where the apps that you and I actually use are built. This modular approach is a really promising path to helping these networks scale.
So let's just zoom out for a second. What we've really been talking about here, this combination of a shared ledger, a peer-to-peer network, and all these dedicated nodes, is that this whole architecture is at its core an elegant solution to the problem of trust. It's a blueprint for creating a system where a group of people who don't know or trust each other can all agree on a set of facts without needing to rely on a middleman.
And that leaves us with a final, really big thought. This whole architecture was originally designed to rebuild trust in currency, to create a digital money system without a central bank. But if you have a blueprint for creating trust, what else can you build with it? What other systems in our world that currently depend on slow, expensive middlemen? I'm talking about things like voting systems, supply chains, digital identity, even property records. What other systems could be completely rebuilt from the ground up on this new foundation of trust?